So we're joined with Stathis from the Robotics group, and tell me a little bit about what you do.
Larry, thank you for inviting us, first of all. Before we start, I would like to have a test for you. I would like you, by the end of this interview, to be able to pronounce my surname, which is Papavstathiou.
Yeah, that won't happen.
Okay.
But
so let me tell you about the Robotics Development Studio. We have a new release.
Yeah.
It's coming out next week on the 15th. And I would like to talk a little bit about Robotics Development Studio. We're doing it's a development platform. It helps robotics developers to build applications for different hardware components for the robotics platform. And we have three main themes. The first one is we have an asynchrony service-oriented runtime. And robotic applications are inherently concurrent applications because we have all of this sensory input that we have to process. And we have developed the concurrency and coordination runtime that provides a framework for developers to think about this problem. The second thing that happens with robotic applications is that they are distributed applications. A typical model is we have a PC that controls a robot. So this is a simple distributed architecture. And we have developed the decentralized software services, which is a framework for building distributed applications. The second thing that we have in Robotics Development Studio is an end-to-end development platform. So our users can use C#, JScript, Visual Basic.NET, and Iron Python to build applications. But what we found out is that because of the nature of the problem, it is hard for newcomers to build distributed concurrent applications. So we have a new tool which is called Visual VPL, and it is a visual environment where our users can use a drawing surface to create an application by dragging various services in this surface. And this is a data flow-based visual surface. And we have found out that with this tool, we have lowered the entry level of our users.
Great.
We also have a simulation environment. And the simulation environment is used by developers that they don't have access in the hardware that they want to build their application, or before they actually start testing on the physical hardware, they want to use the simulator to debug their application.
So let's talk a little bit about these users. Who is the typical users of Robotics Studio?
So we have a wide range of users. We're starting from the hobbyists, researchers and academics, and we have industrial users. Actually, as part of this release, we have two new customer case studies. One is from a French company called Robosoft, and they're building robots in various areas, industry, services robots, medical robots in France. And what they have found out is by introducing Robotics Development Studio in their development process, they have first of all lowered the entry effort that's required from new developers. People know how to use Visual Studio tools, and it is a little hump to learn the additional tools that they need for Robotics Development Studio. The second thing that they found out is that it is 5 to 6 times faster to build code. And this is because we have built CCR and DSS specifically for these type of problems. So it is a model that is very naturally comes to this type of applications. And finally, they can debug their code 10 times faster. And this has to do with all of the debugging infrastructure we have in DSS, but in addition to that, we have the simulator, which is a great tool to debug your application before you move to the real hardware, where you have all sorts of additional issues to deal with.
Now, when you say it's 10 times faster, is that just a saying, or do you have like some actual metrics that have supported that?
Yes, this is not what we are saying. This is what our customers, in this case Robosoft, is saying. So they have been using RDS for some time now, so it is an empirical metric, but it's coming from a customer.
Great. So give me some of the highlights of this release. What are some of the major features that separate it from the previous one?
So we have a number of additions and improvements in this release. In our simulation environment, we have new environments. We have an apartment, an urban environment, and an outdoors environment. We have added sensors to the simulator. We have changes our tutorials, so it's more accessible to more entry-level users. We have done the same with VPL. We used to have a courseware for CAs undergraduates. And what we found out is that for all of our users, the type of lab exercise that we had was very valuable.
Yeah.
So we have changed them to be hands-on lab, and we have rewritten them for wider audience. We have a new application called DSS Log Analyzer. It's a great debugging application for distributed applications. Already in RDS, in previous releases, we had a great infrastructure for debugging. But what is very hard with distributed applications is to be able to correlate the information from the different services. So this tool comes to solve this problem. Finally, we have a very active community. And we have been receiving a lot of feedback from the community regarding the various features and some bug reports. So in this release we have fixed around 60 to 70 bugs, and we have incorporated a lot of new DCR design changes proposed by our users. We're also going to have a new website which will help especially newcomers in the robotic space to easily learn our tool chain and how to build applications for robots.
So what's the lowest barrier for someone? What kind of programming aptitude do I need to have to be able to go into Robotics Studio? If I'm just like a novice that does a little bit of JavaScript, am I going to be able to find my way around?
Yes. So we have a range of tools. And they start from the hobbies that they now get into the robotic space. Typically they will use VPL, which is our visual programming language, to start using existing services and orchestrating the services to write an application. And it goes to the really advanced folks that they need to build extensions for new hardware, and they have to create new services using CCR and DSS. So we have a wide range of users.
And I saw you have a few different versions of the development studio this time. So tell me about those.
So this is something we introduced in 2.0 release, in 2008 release last November, and we're continuing with this release. We have 3 versions. The Express version, which is available for download for free from our website. We have the standard version, which is an extension to the Express version. It allows the distribution of the runtime to environments, to enterprise environments. It supports more distributed applications, more advanced applications that typically the hobbyists don't write. And we have some additional simulation environments that we provide. So this is the standard edition. It's available for users to buy online. And finally, we have an academic edition, which is available from DreamSpark for students and research and academics that they want to use our application.
Great. So students can go in for free and just try it out.
Yes.
Great. And where do I go to find out more about this and get started?
It's under www.microsoft.com/robotics.
Excellent.
And with our release, we're going to have our new website.
Great.
Also available.
Well, thanks for coming today.
Thank you, Larry.
All right, now we're here with Stuart McLeod from the Robotics Group.
Larry.
Good to see you.
Nice to see you.
Yeah.
How you doing?
So tell me a little bit about Robotics Studio.
Well, we're really excited about Robotics Studio 2008. We've made a lot of great improvements that we'd love customers to know about. The first thing is that Robotics Studio is an integrated development environment. And what makes it so cool is that we make it easy for people who are even novices to the field of robotics to get started. We have an easy drag and drop visual development environment known as VPL, or Visual Programming Language. The second thing is that we provide the infrastructure and tools where you can build very scalable concurrent applications. And then,
what exactly does that mean for the novice out there?
So it's very hard to write a multi-threaded applications on the Windows platform. I've been at Microsoft for 16 years, and it's just so difficult for people who are new to our platform to create scalable multi-threaded applications that are robust and reliable. It's really difficult to protect shared resources, memory, and and whatnot, and they always get it wrong.
Yeah.
And so we created this new library called CCR, which is incredibly cool, Concurrency and Consistency Runtime. And what it does is it provides a simplified way to create asynchronous applications. So we do all the hard part for you, so you get the scalability and the throughput.
Nice.
Now, why is that useful in a robotics environment? Because you have a ton of sensors.
Yeah.
You're always reading all of these sensors, and you want to, be reading them in parallel.
Yeah.
So having this infrastructure is good. But it's not limited to just robotics. We also make it available separately from Robotics Studio for people who want to build highly scalable enterprise applications. And so, for example, let's say you had some kind of web service and you needed a lot of power on the back end to service your customers. CCR would be a great choice for that. What it also allows you to do is you can program multiple robots to work together to cooperatively solve some kind of goal. Now, you take that
you can create your hive.
Yeah, exactly.
Your hive swarm.
It's a swarm, baby. No, you can, and what's really cool is that for people who are just getting started, when you don't have a lot of money for hardware, being able to take advantage of our simulation technology with an integrated physics engine helps so much.
Well, that's one of the other things I think is really one of the coolest things about the Robotics Studio is the simulation environment. I mean, it looks incredible. It looks like a video game almost, and it just the interesting thing about it is that you can develop for the real world without actually having to get into the hardware part yet.
That's right, and what a great time saver it is. So internally, we use it to develop applications all the time because we're way more efficient and effective because we're able to create and immediately test different kinds of algorithms in a variety of environments. You can customize the environment. We can extend it. You can create things called sprites, so you can put like a camera and see exactly what your robot is seeing and see that in the environment. Or
awesome.
You could use it to output debug information.
Yeah.
And I know that helps me a lot, understanding, well, why is the robot doing this or that, in let's say some kind of maze, example. But the other thing is that I think is really important is that multi-threaded programming is hard, but creating distributed, loosely coupled applications is even harder. And how do you make them robust? How do you make it so that you can create a part of the application and have it fail and not cause the entire system to crash?
And what's the solution, Robotics Studio?
DSS provides these services that makes it possible to properly isolate the various components so that your application can respond gracefully and predictably. And that's what makes it easy to create applications that otherwise would be far beyond the reach of most programmers today.
So what's the footprint on this? Is it a lightweight environment? Is it?
DSS and CCR are both very lightweight. In fact, both of them, we run on everything from Windows XP all the way up to Windows Server 2008, 32-bit or 64-bit. The simulation environment, we sit on top of, .NET, and we use .NET 3.5 SP1, and then the simulation technology requires Shatter 2.0 or above, and at least 64 meg of RAM on your graphics chip. So it would fit most of the workstations.
A modest PC.
Yeah, most of the workstations out today. So it is actually very lightweight, and in terms of having that as a tool, you just can't estimate how important it is to let you get something done in a day or two that otherwise you'd spend a week resetting up the hardware for and resetting up to actually solve some specific problem you're working on.
Well, I'm looking forward to seeing a simulation of this. So
yeah, we'll give you a demo of both simulation, and we'll also give you a demo of what we call DSS Log Analyzer. And this is a very cool tool that we're introducing with 2.1 that allows you to understand all the messages that are being passed in the distributed environment.
Great, thanks.
Larry, great to talk to you. Thank you.
All right, we're here with Trevor Taylor from the Robotics Group now, and you're going to show us a simulation of this.
Yeah, so I'll show you a couple of things. I'll show you what we call our DSS log analyzer. As Stu's already said, when you've got lots of different services out there sending messages, there's stuff flying everywhere, when you're trying to debug it, it's all happening in real time, it's very hard.
Yeah.
So what you can do is record all of that and then just replay it later at your leisure and look at individual messages.
Very cool.
This is a new feature. I think it's really quite useful. The other thing I'll do then is just flip over to our simulation environment, and I'll show you how you can use different sensors and drive around inside our apartment model, which is a pretty cool model. It's got all the standard things you'd expect to see in the average apartment.
Cool.
So what I have up here is the log analyzer. I've got some pre-recorded logs that I created using the simulator. And at the moment it's showing you the message traffic between the different services. So the little ovals that you see around the outside there, they're the different services. They've got labels on them. And you'll see that there's some lines between them. This is the message traffic. The thickness of the line indicates how many messages were sent. So you can immediately get an appreciation of what's the busiest area of traffic here. So you can start looking for bottlenecks. Yeah, exactly. I can slide the little slider down here and actually change that value so that I can adjust the threshold for how many messages show up here. Now what I've got is a lot more messages being shown, ones that I probably don't care about. So I can adjust that. I can also go through and turn off particular services so that if I'm not really interested in them, I'll just take them out of the equation. They'll disappear.
So you can isolate to try to trap for some particular problem that you're having or something you want to find.
Yes. Generally, when you're debugging a single service or maybe two services communicating with each other at one time. You're not worried about all the other stuff that goes on in the background. Now, clearly, there's some housekeeping. Some of these services I don't care about. I mean, they're DSS. They don't have anything to do with me directly, so I don't need to actually go and look at them because as long as they do their job, everybody's happy. But if I'm trying to debug a particular service, then I can go and say, okay, I'm interested in this particular message flow here, and I want to look at more information on that. Now, if I flip over to the Message Details tab, what I can see is individual messages. In this case, you can zoom in, so I can move around in time by just scrolling. Down the middle here, I've got each of the different services listed, and then there's these little blue bars that indicate there was some message traffic at that point in time. So there's a time axis across the bottom here. I can adjust the scale if I want to, because sometimes I need to find something, and to find it looking very closely in at messages can be difficult. It's like a needle in a haystack. Yeah, exactly. So what I can do is zoom out, get an idea, well, you know, that problem when I was running it happened about 23 seconds into this test run. So I can go to that area and then expand it out and see a bit more clearly exactly what's happening. You'll see down in the bottom corner here, we've got a camera view. Now this is in simulation, and this is a view from the camera on the robot. So that information is actually stored in the log file.
That's great.
And I can replay that, and I can step through it, and I can see exactly what the robot saw. If I was writing some sort of algorithm that was, say, looking at the floor and figuring out if it was clear so I could drive there, then I could look at my service details, I could look at the camera image and go, you know what, they don't match. I've got a problem in my algorithm. There's something wrong.
So you can follow your timeline, just keep watching that window
and I can see those.
That's awesome.
Or alternatively, I can simply click on one of these messages. This is a simulated infrared message. And then on the right-hand side here, we see message traffic backwards and forwards. So we see the requests and the response that come back. Because in most cases, that's the way that things work. You ask for something, and the service gives you back the answer. Fine. You can see those related messages displayed there in what we call the causality view. I can also go and look at the actual details. If I turn on the particular viewer in here, I can look at the raw data for any of these messages. Now these viewers are things that we can load. We've designed this architecture in such a way we can add additional types of viewers if we feel like it. This particular viewer allows me to see the actual data that was sent in the message. So I can go right down inside any of these messages and have a look at it. Yep.
So you have that webcam view down in the corner, but what if I needed a different view, or I wanted to be able to see more than I'm getting with that one? Can I add another camera?
You can, but in that case you'd have to go back and rerun your test.
Sure.
Because what you've got here is a recorded log file, so it's only what happened in the past. You can't sort of go back and take a different viewpoint.
So it's like scrubbing through a video, so you'd have to re-render it.
Yeah, so it's already recorded. That's what you're stuck with.
Yeah.
If you want to do it again, you add your extra camera, you run it, then you can look at two cameras.
Great.
Okay, I think that's probably enough of a background on the log analyzer. I'm going to switch over now to our simulation environment and show you how that works.
So we've got the simulation here.
Yes.
And this is kind of a boxy little robot.
Yes, it is, and I've done that deliberately. This is just a sample robot that we use for the tutorials.
Yeah.
So it's not supposed to look pretty. What you can do is you can use a thing called a mesh, and you can put that over the top of it, so it actually looks like a real robot.
So you can make any robot you want.
Yeah, of course.
All right.
And we have like a Lego NXT and a Pioneer and
Robbie
some other
the robot?
robots.
A little lost
Not
in
yet.
space? No?
We could
Okay,
work
we'll
on
work
that.
on that.
So you'll also notice in there that there's some red flashing dots.
Mm-hmm.
That's a laser rangefinder which is sitting on top of the robot. So it's determining the distance to all the nearby objects. Now, a real laser rangefinder actually uses infrared, you can't see it. But for the purposes of the exercise, for debugging and so forth, that's really handy because you can see exactly where it's hitting things. And what I'm doing is I'm running something called the dashboard, The dashboard allows you to drive a robot around very easily. In fact, I can use, plug for Microsoft, Xbox controller, and I can drive the robot using that. So you'll notice in the background there, the robot's moving forwards, backwards, until I push the joystick. And also down the bottom of the dashboard, the laser rangefinder information is being displayed. You can see that changing as the robot moves.
So that laser rangefinder there, is that coming from the wireframe that the room is built from, or is that actually detecting that from the simulation?
It's effectively detecting it as though they were real objects. So what it's doing is something called ray casting. It basically sends a ray out in the simulation until it hits an object. So it's exactly the same as if it was a real laser firing off laser beams out there and bouncing back.
Very cool.
Yeah. So I can use the Xbox controller, as I said. I can turn the robot around, and I'm going to aim it at the wall, and this is deliberate so that I can get a little bit closer to the wall. And then what I'll do is flip over to another window that we have here. This particular window has information in it which maybe not showing up too well there given the colour, but basically it's showing me the distance to the wall using an infrared range detector.
Yeah.
It's also got a compass heading, so as I turn, the information changes. And notice that we've got this sort of black and white picture on the left-hand side. You might be wondering, why is it black and white? We've written our own little bit of code here, and what it does, it's doing something called an edge detection. So in image processing, you can take a camera image, so this is working off the raw image that the robot sees, and then you look for lines in that image which are edges. So for example, you can see the door frame, you can see the chair down the end of the hallway there, you can see the
molding on
edges
the walls,
on the cupboards, and so on. You can even see bits on the floor. And by adjusting the thresholds on that, you can cut things in and out. So you can see the major objects around you in a visual sense. We can also, in the simulator itself, we can see what the robot sees by saying, you know what, I'd like to see the simulated web camera in a separate window. And there it is. And now you see the color version of what you just saw in black and white.
So this is an actual camera that would be on the robot itself.
That's right.
Yeah.
So if you had a real robot, real camera, you'd be seeing this. And as you drive around, you'll notice that the scene changes. I can see there's the dining room and table and chairs and so forth, and a bookcase and all the sort of stuff that the robot can see. Whereas in the main view, down the bottom right there, that's not changing because I'm not moving that around. If I want to change that, I can click on it and I can just wave it around using the cursor. So I can go and have a look around the room. That's a sofa. I can have a look over here. There's the kitchen, microwave oven, etc. Over here's the entryway, etc.
How many environments like this do you have?
We provide 3. The Express Edition that Stathis mentioned only has the apartment model, which is this one. The academic and standard editions also have an outdoor environment, which has got trees and hills and rocks and all the stuff you see in the outdoors. And it's got an urban environment, which has got roads and buildings and all that sort of thing, and vehicles in there that you can actually drive around.
Yeah. Very cool.
So that gives you the ability to start doing real-world stuff without any real-world hardware. The nice thing about this is, if you've got no money, you can download RDS for free, Express Edition. You can run all of this, you can write code, you can drive around a virtual robot, and it costs you nothing.
Well, congratulations. It looks great. Thanks for coming today.
All right, thank you.